Hello everyone and welcome to my video tutorial. Today, we will be diving into the fascinating world of sets, specifically focusing on the set of real numbers. Sets are fundamental in mathematics, and understanding them is crucial for many other concepts. So, let's get started! So, what exactly is a set? Simply put, a set is a well-defined collection of distinct objects. By well-defined, we mean that it's clear whether or not an object belongs to the set. We use braces, these curly brackets, to enclose the elements or members of a set. The elements can be words, symbols, numbers, or anything you can think of to describe it. For example, we can have a set of primary colors, red, blue, and yellow. Or the set of the first 5 positive integers, 1, 2, 3, 4, and 5. Notice that each object is distinct and clearly belongs to a set. There are two primary ways to express a set, the Rooster method and the rule method. The Rooster method, also known as the tabular method, is simply listing all the elements of the set within the braces. For example, if we have a set S containing the numbers 1, 2, 3, 4, and 5, we write it as S is the set containing the elements 1, 2, 3, 4, and 5. Now let's talk about the rule method, also known as set-builder notation. This method involves giving a criterion or rule that determines whether an object belongs to the set. For instance, if we want to define a set C of all natural numbers less than 6, we can write it as this. This reads as the set of all x such that x is a natural number and x is less than 6. Element, simply an object in a set. We use this symbol to indicate belongingness. For example, if we have a set A containing the elements A, C, D, 1, M, Q, and Y, we can say that letter A is an element of set A. Conversely, we use the symbol to indicate non-belongingness. So this one means B is not an element of set A. Universal set, denoted by this, is a set containing all objects or elements under consideration. All other sets are subsets of the universal set. Subset, a set whose elements are all contained in another set. Now let's differentiate between two types of subsets, proper and improper. Proper subset of a set A, denoted by this symbol, is a set that contains some but not all of the elements in A. If a set is not a proper subset of set A, then this symbol is used. B is a proper subset of A because all elements of B are in A. But A has an element, which is 3, that B does not have. Improper subset of a set A, denoted by this symbol, contains some or all of the elements in A. It's interpreted as a proper subset or is equal to. If a set is not an improper subset of a set A, then this symbol is used. B is an improper subset of A because it contains all the same elements as A. Now let's take a look at some special types of sets. Null set or empty set, a set that contains no elements. It is denoted by this or this. For example, the set of all even numbers that are odd is an empty set. Disjoint sets, sets with no common elements. If the intersection of sets A and B is empty, then sets A and B are disjoint. Equal sets. Sets having the same or identical elements. If A is a subset of B and B is a subset of A, then A is equals B. Sets A and B are equal because they contain the same elements, regardless of the order. Cardinality of a set A, denoted by this symbol, refers to the size or number of elements in a set. For example, if a set A contains the elements 1, 2, and 3, then the elements of a set A is 3. Equivalent sets. Sets with the same cardinality. If the number of elements in set A is equal to the number of elements in set B, then sets A and B are equivalent. Now let's explore the basic operations we can perform on sets. Union of sets A and B, denoted by this symbol, is a set containing all distinct elements present in sets A and B. Intersection of sets A and B, denoted by this symbol, is a set containing all distinct elements common to both sets A and B. Complement of a set A, denoted by this symbol, is a set containing all elements present in the universal set but not in set A. Difference of sets A and B, denoted by these symbols, is a set containing all elements present in set A but not in set B. And that concludes our tutorial on the set of real numbers. We've covered the definition of a set, ways to express sets, elements, subsets, special sets, and basic set operations. I hope you found this video helpful. Thanks for watching!